So this is Claymore. Claymore, say hello. And Claymore is going to help us with chemical bonding today because Claymore really, really likes to sit on paper. So Claymore is going to visit with us. Here we go. First of all, why do bonds form? Okay, so why do bonds form? You guys may have remembered, we've talked about it before, that everything wants to go to a state of lower potential energy. Okay, so we have our potential energy, and things want to go down. That's why balls roll downhill. That's why leaves decompose in the fall. That's why if I stumble going up those 2 stairs in my classroom, I'm going to fall down and not up. We can think of all sorts of things where the potential energy will lower. That's the natural state of the universe. All right, so why do bonds form? Let's take a look at what's called a potential energy well. So I'm going to draw this now, kind of biggish, so I can label it. Bye-bye, Claymore. Okay, and what we have on the x-axis is the internuclear distance. Sorry about the handwriting. Internuclear distance, or the distance between atoms, and we have potential energy increasing on the y-axis. And then we are going to draw what is actually called a well. Doing this in pen may be a little bit tricky, but I've got a straight line to follow out here. Whoa, how about that? Low potential energy, high potential energy, medium potential energy. And what we're going to do is pretend we have 2 hydrogen atoms that are coming toward each other, but they are simply 2 hydrogen atoms at this point. So let's give them both 1 proton. And when they're way out here, the hydrogen atoms don't see each other. So they're traveling right on this spot on the potential energy well. And they're going to get closer and closer and closer. And eventually they are going to start to recognize that there is another hydrogen atom there. Well, what happens when they see each other? Well, let's look down here. Well, you have 2 hydrogen atoms that are supposed to be the same size, and each of them has an electron. The electron and the proton are attracted to each other. But when they get to a certain distance apart, this electron begins to become attracted to that proton. This electron begins to become attracted to that electron, and you have a situation where the electrons, instead of just being around the 2 atoms, move in between the 2 atoms and form a bond. So they see each other. Once they start down the slope, they can't do anything else except bond. So here they are. The electron clouds are overlapping, so it looks kind of like this, with the electrons in the middle. The protons are in the center, and each electron is attracted to each proton in an equal fashion. So the energy has gone from here to here. The distance between this point, the bottom of the well, and this point, which is this horizontal line, is called the bond energy. The bond energy is the amount of energy that the 2 atoms have lost as they've made a molecule. The distance between the atoms here, when they are at the base or the bottom of the potential energy well, is called the bond length. Length, I hope. So that's the bond length. That's the distance between the 2 nuclei. There's a couple ways you could break a bond, but right now this guy is pretty happy. You've got a hydrogen where my fingers are, and they're just vibrating back and forth, and they're going to do that forever. The small vibrational mode, back and forth, back and forth, back and forth. The bond is acting like a spring, and they're going to stay like that until something comes in. That something would be energy. So if energy comes in, instead of doing this, all of a sudden they're going to start wildly going apart. They could go back up here When they get over this distance, they can spring apart and the bond is broken. Or the electrons could get too close to one another, get up here, where you've got an almost overlapping set of protons and electrons, and it would spring apart from being too close. But that's why bonds form. You have atoms getting closer together. They don't see each other. They don't see each other. They begin to see each other. The electrons are then attracted to both sets of nuclei. In this case, it's just a single proton. They start to shift around. They get in the middle, and then they are attracted equally to both nuclei, and you have formed a stable molecule. So that's it for why bonds form.